So let's get this done. All right, I guess that's good enough. So let's start. So it's been 3 months since my last proper video, and we're not here to talk about that. We're here to talk about a project that I did this year that I'm particularly happy about. So this year, for one of my lab classes, I had to learn about PLCs. Let's say it was a 2-semester affair. So in the first semester, we were introduced to the PLC, Programmable Logic Controller. The basics of it, like what we went through was like, I think we dealt with timers, inputs and outputs, the latch, I guess also the program flow. So just the basics of PLC. I'm not really talking about that. That's not what this video is about. But the fun part was in the second semester, where we had to actually use that knowledge to design a working system. So the system that we designed was a conveyor belt system. So the setup was basically you have 2 conveyor belts, and you're supposed to what is this? So yeah, you have 2 conveyor belts. Conveyor belt 1 has a magazine. This magazine has the pieces which you're going to sort, which are basically cylindrical discs. One side is coated white, the other side is coated silver. The white side, we call it the capacitive side, and the silver side is the inductive side. And there are a bunch of sensors. There's a capacitive sensor and an inductive sensor. These sensors are used to identify if a piece is on the conveyor belt, and also can be used to sort. The conveyor belt is an electropneumatic system. That's why you can hear it like whoosh, like in this place. And it also has quite a number of valves for controlling the airflow and all that. Each conveyor belt comes with its own sensors, and also it has outputs that can be controlled. Things like plungers, the motor that actually runs the conveyor belt, and all this can be accessed through panels attached to each motor. It is through these panels that you actually interface with the PLC to write your ladder diagram and get things running. The PC that was used was a Siemens. The CPU was 224. It's kind of like an old CPU, but it kind of does the job. Software that was used for writing the ladder diagram was the Step 7. Just a quick rundown of the Step 7. You have the program block, whereby you write your main program, or you draw your ladder diagram. Mine was 38 lines long, and you have a symbol table. You gotta put your variables, give them good names. The I's are inputs, M's internal relays, Q's outputs, T's timers. You can see like S0 emergency push button, S1 start green. So those are the basic different kinds of things that you get. So yeah, so this is basically what controlled the entire system. If you look at the symbol table, you have your Y7s, your Y6s, which are the solenoid valves, and you have your K1s and K2s, which are the motor relay. I guess that's enough of like background. So let's get to something a little bit more interesting, like a demo. You're probably wondering why the pick and place unit reverses direction. No, it's not a video effect. That's actually just the stop situation. There are two scenarios under which the normal operation of the PLC will be interrupted. There's the stop situation and the emergency situation. In the stop situation, basically, everything is stopped, the normal operation is stopped, and the pick and place unit goes back to its original position. The emergency stop, on the other hand, freezes everything in place. If it's carrying a piece, it still holds on to the piece, and the pick and place unit will only go back to the initial position when it has explicitly been told to by the press of a button. So yeah, so that's just the entirety of the project in a nutshell. There is so much more I could get into from this, so many lessons learned, but hey, let's keep this short and sweet. The next video though will be coming much sooner than 3 months. That's a guarantee.